4 awesome chicks and came home at 2 a.m. Oh, I don't know. Tell yourself your own story, right? Just as long as you remember the quadratic formula, okay? Sing a song, tell yourself a story, make up your own mnemonic, however you want to do it, but I expect you to memorize the quadratic formula by next week's exam, okay? Now, let's use a couple examples using the quadratic formula. Okay, a couple of examples using the quadratic formula. Okay, here's our first quadratic equation: 4x squared plus 6x plus 1 is equal to 0. Now, if you look at the formula, you'll see that in general form, you got to have your quadratic in general form. You have to have a square term, a middle term, a constant, and then one side equation must equal 0. You can't use the quadratic formula unless you have general form. Now, the number that's in front of the square term is a. So a would equal 4. The number in front of the middle term is b. So b is 6. And the number without the variable is c. The constant is c. A, B, C, alphabetical order. Okay, now, x is equal to the opposite of b. Opposite of 6 is negative 6. Plus or minus the square root of b squared minus 4 times a times c all over 2a. I took those numbers and I put them into our quadratic formula. B is 6, a is 4, and c is 1. Now I'm going to grab my calculator and I'm going to find out what this number is underneath the square root first. So I get 6 squared minus 4 times 4 times 1 over, we need to multiply by 1, and I get 20. So x is equal to negative 6 plus or minus the square root of 20. 2 times 4 is 8. Now this is not considered proper radical form because 20, the number in the square root of 20, is divisible by a perfect square bigger than 1. We know a perfect square is 1, 2 times 2 is 4, so 4 is a perfect square. 9 is the next one, then 16, etc., etc., etc. 20 is divisible by 4, a perfect square greater than 1, so that makes this not proper radical form. So what I do, I make a box for the perfect square and then a box for the leftover. And the biggest perfect square that goes into 20 evenly is 4, so 4 goes into the first box. This is my perfect square box. And then 20 is 4 times 5, so 5 goes into the second one, the trash. I call it the trash, the leftovers. And now I know the square root of 4 is 2, so x is equal to negative 6 plus or minus 2 squared of 5 over 8. Take the square root of 4. Now I still don't have proper radical form because all the numbers on the outside, all the numbers except for the number on the square under the square root, just the numbers on the outside of the square root, negative 6, 2, and 8 all share a common factor of 2. So I want to take a 2 out of everything. So x is equal to negative 3 plus or minus 2 squared of 5 divided by 2 is just the square root of 5. And 8 divided by 2 is 4. Now that's two solutions, remember. It's negative 3 plus the square root of 5 all over 4. And negative 3 minus the square root of 5 all over 4. This right here is called the exact value. That form of the answer is known as the exact answers or the exact value. The decimal approximations are when we find a decimal for the square root of 5. So I'm going to go off here to the side. I'm going to use my squiggly equal signs for approximately. And I'm going to use my calculator to find a decimal approximation for the square root of 5. And the square root of 5 to the nearest tenth is 2.2. So I get negative 3 plus 2.2, hit enter, and then divide by 4. So 1 decimal approximation is negative 0.2 for x. And that's negative 3 minus 2.2, enter, divide by 4. And the other one is a negative 1.3. Now this form of the answers is known as the decimal approximation. Okay? So on your exam, I may ask you for the exact answers, that's the one with the square root in it, or a decimal approximation to the nearest 10th. Decimal approximations are the ones that use your calculator to come up with the value or approximation for the value of the square roots. Exact values are the ones that have the square root in them. Okay. Any questions about quadratic formula yet? All right, let's try another one. Let's try 3y squared minus 2y plus 7 is equal to 0. Alright? Now, first thing, you have to make sure before we try to use quadratic formula, we have general form. You have to have a square term, a middle term, a constant, and it must equal 0. We do have general form here, so a is the number from the square term. B is the number from the middle term, so that's a negative 2. And C is the number without the variable, the constant. And that's y is equal to the opposite of b. Opposite of negative 2 is positive 2, plus or minus the square root of b squared, so it would be negative 2 squared. Now make sure, especially when you put that in your calculator, you put that in parentheses. Because we want to make sure we square a negative 2 and not 2 squared and then change the sign. Minus 4 times a times c. All over, make sure your fraction bar is underneath the 2 as well. 2a. All over. Now I'm going to grab my calculator. Make sure you put the negative 2 in parentheses if you're going to use your calculator to square it. Because if you don't, then your calculator thinks you might mean 2 squared and change the sign. You want negative 2 times itself. Minus 4 times 3 times 7 is negative 80. So y equals 2 plus or minus the square root of 80 over 6. Oh, negative 80 over 6, sorry, negative 80. Negative. Now, we said, remember, we just did a whole thing about domain, and we said that you can't find the square root of a negative number. And my number underneath the square root is a negative 80. Alright? You may remember, mathematicians didn't like that, especially with quadratic equations. They wanted to be able to solve all quadratic equations. So they invented a whole new set of numbers called complex numbers, which is based on the number I, which is the square root of negative 1. Alright? So it doesn't have any real solutions, but it does have complex solutions. So the first step is to take out the I to put it in proper form. You gotta take out the I. So I say 2 plus or minus, and I make this I times the square root of 80 over 6. And now we need proper radical form because there is a perfect square that goes into 80. I'm not done with my radical yet. I gotta make sure that then when I end, this number in the square can't be divided by any perfect square except for 1. So I gotta find the biggest perfect square that goes into 80. Perfect box, not perfect box. The biggest perfect square that goes into 80, well, let's see. 4 goes into 80, but so does 16, and 16 is a perfect square. So we use the biggest one, 16. And 80 divided by 16 is 5, so I put 5 in the leftover. And I know the square root of 16 is 4, so I'll rewrite this to be 2 plus or minus. I'm going to put the 4 in front of the I, so I'll get 4i squared root of 5 all over 6. And that's proper radical form, but you look at the numbers on the outside of the square root, 2, 4, and 6. Do they share a common factor? 2, 4, and 6? Yep, they're all even. So that means I can divide everything by 2, and as long as I do it to all three numbers, it's legal. If I divide everything by 2 to put it in proper form, I get 2 divided by 2 is 1. 4i squared of 5 divided by 2 is 2i squared of 5. And 6 divided by 2 is 3. Now this would be the exact values, or these would be the exact values. I should use the correct tense. These are the exact values. Okay, and because of the I, there is no decimal approximation. Complex numbers do not have a decimal approximation. So there's no decimal approximation. All right? Any questions about the quadratic formula? All right, there's one other method that I want to talk about you solving square roots for here, and this is called the even root property. Quadratic formula works for every single quadratic, all right? But the even root property only works for special types of quadratic equations, not all of them, but it's a lot quicker than the quadratic formula, okay? Let me tell you what the even root property says, first of all. It says if x squared is equal to some number k, then x is equal to plus or minus the square root of k. It's the property that says you can take the square root of both sides of the equation and it'll stay equal. So the even root property is handy when it works with quadratics. Whose form is ax squared plus c is equal to 0, where there's no middle term. It's just a square term and a constant, and it equals 0. So let's try this. My directions are going to say solve using the even root property. And here's my first one. 3x squared minus 15 is equal to 0. Okay, no middle term. All we have is a square term and a constant. And what we're going to do is we're going to solve for the x squared, and then we're just going to take the square root of both sides. Okay, that's what the even root property says. So I'll start here. I'll add a 15 to both sides. So 3x squared is equal to 15. And now I'll divide both sides by 3. So x squared is equal to 5. And now we'll take this even root property, we'll take the square root of both sides. Don't forget plus or minus on the number side, because there's two numbers when you square and you get 5. One's a positive number, one's a negative number. So we need plus or minus in front of the square root of 5. And so x is equal to plus or minus the square root of 5. That would be the exact value. And for the decimal approximations, I need my calculator. For my decimal approximations, I need my calculator. And the square root of 5 on my calculator is approximately the nearest tenth, 2.2. So that would be my decimal approximation. Yeah.
So it's like quite similar to almost like perfect squares.
Yes. Okay. All right. Let's try one more. I'll let you guys try this yourself. See if you can walk through my steps. 4x squared plus 16 is equal to 0. Find the exact values for x using the order property. negative 16 to both sides. Divide both sides by 4 to get the x squared alone. Take the square root of both sides, don't forget plus or minus on the number side. So x is equal to plus or minus I plus or minus the square root of negative 4. I took out the I, because it was a negative number in the square root, so I made that I times the square root of 4, and the square root of 4 is 2. So my solutions are x equals plus or minus 2i. And there would be no decimal approximations because of the I.
So if the answer turned, or you were looking at the part of the answer that was plus 2i, it would be like above the x line. If you're looking at the answer minus 2i, it'd be
2i
like
doesn't have a
below the
value
x.
like that. You can't plot them on the graph.
In electricity, they use the term J, and it's graphical.
Well, not for our purposes. Okay? Anything else about this?
Do you always, like for the one above, when we're doing decimal approximation, do you always want just to nearest tenth?
I'll tell you. Generally, I'll tell you. Convention is you go one decimal place farther than the numbers you're given. So since we were given integers here, we would go one place farther. That's sort of the convention. But in general, I'll tell you. But nearest tenth is usually what it is. Okay. Anything else? Okay. I think I gave you these practice problems before. But in case not, you should be able to finish this now. We have one more method we're going to talk about on Monday, solving quadratics. Section 3.2, 27 through 43i. Okay. Any questions about quadratic formula even property? Okay, any last minute questions before you take your quiz? For the, yes.
Can you just go over the, reflection shape, translation?
What about it?
The term.
Terms? I don't know what it means. Translation is a shift. Dilation is a stretch. Reflection is a flip. That one. For your quiz, you just need a calculator and a pencil. If you want some scrap paper, you can use some scrap paper.